Here I've got a facsimile of an exponential curve. I'm going to declare that this curve goes through the point 0, 1, and that its doubling displacement is 1, so that by the time we get from 0 to 1, the graph, the y value will have doubled, and since the y value here is 0, we move over one doubling displacement. The y coordinate at this point has to be 2. And if we move the in the direction opposite the doubling displacement for the same distance, the y coordinate is going to have to become half as great, so the y coordinate here is going to be 1/2, meaning that here we have the point 1, 2, and here we have the point -1, 1/2. If I sketch a slope, a chord from this point to this point, what's the slope of this chord? Well, the rise is from 1/2, which is the y coordinate here, up to 1, so the rise is 1/2, the run is 1. So I'm going to call that chord 1. Slope is 1/2. Now, chord 2 is going to go from this point to this point. Okay, what's the slope of that? Well, it's very easy to see that we move over 1, we move up 1. So chord 2, slope is 1. Now, if I draw a tangent line at this point, the slope of the tangent line is less than that of chord 2, greater than that of chord 1. So that the slope of the tangent line at the x equals 0 point is bigger than the slope of the chord on this side, which is 1/2, and less than the slope of the chord on the other side, which is 1. Now, remember the big deal number that we're looking for is the doubling displacement that makes this slope 1. So clearly, this doesn't do it. The slope is too small. Okay, slope is less than 1, no good. Now, if I replace the 1 by 1/2, then what do we have? This will be the point -1/2, 1/2. This will be the point 1/2, 2. Then chord 1 is going to have what slope? Well, if now the run is 1/2, the rise is still 1/2 because we're going from the height here is 1. If this is a doubling displacement, well, if this is a doubling displacement, then the value has to double from here to here. So it's got to be 1/2 here in order to double and end up at 1 here. Then if we got doubling displacement 1/2 here, we got to double the 1 to get the y coordinate here. So it follows that these points are as we've indicated. Okay? Now, if the chord, in this case, the slope is no longer 1/2, and here the slope is no longer 1. Well, you should be able to figure out what the slope is. And then replace the numbers of those two slopes. Well, replace the numbers I'm eliminating here with those two slopes. So, slope what? Slope what? Replace this number, replace this number, and draw a conclusion. Now, in general, again, we're looking for the doubling displacement that gives us a slope of 1. Okay, so what we're looking for there then is a number to put in for our doubling displacement, such that if we do this, the slope of the tangent line is 1. Now, finding the slope of chord 1 and the slope of chord 2, it's going to be difficult to find those slopes. The best way to narrow down the doubling displacement is to actually construct a graph with that doubling displacement and measure the slope of the tangent line. Figure out the slope of the tangent line. The best figure out the doubling displacement that gives you a tangent line slope as close to 1. So doubling displacement such that tangent line slope is 1, and there's a question mark. Okay, figure this out, then think about this question.